All right, lesson 81. Hopefully you aced your test yesterday. Um, yeah, hopefully that worked out for you. All right, so lesson 81 is tackling something with circles here. It's called central angles and arcs. I'll explain what those terms mean here. Not a whole lot of information. This video probably won't be as long as some of the others. So just start here. So the very first thing that you need to know is if you stand here and you spin in a circle, what do people say you did? Oh, he did a 360, turned the whole way around. Why do you say 360? Because in a circle, there are 360 degrees. Literally going the whole way around is 360 degrees. So if you only go halfway, it's 180 degrees. But you need to start with that information. If you go the entire way around a circle, if you spin in a circle, you spun 360 degrees, which is why cameras are advertised as 360 cameras. You can see the whole way around them. All right, so that's the first thing you need to know. Second thing you need to know is a central angle is any angle that has its vertex, its point where the two lines come together, if that is in the center of a circle. So right here, this right here is a central angle because its vertex is in the center. That's the reason to call it central angles. So pretty much it's an angle that uses the center of a circle as its endpoint, where they join together. Just facts here. An arc is then the point. So if you take an angle, or just the central angle, it's the distance, it's the segment of the circle between the two endpoints of the angle, so where it's intercepted. So right here is where it hits the edge of the circle, and right here. So the distance between there is this much of a circle. That is your arc, right? That's what your arc's going to be. Obviously, if this arc is half of the circle, it's a semicircle arc. Literally goes from here to here. There's a straight line across there. It's the angle. It's a semicircle. A major and a minor arc. There's two differences. A major arc is anything bigger than a semicircle. So it's going to be over half the circle. It's going to go the whole way around like that. That is a major. A minor is anything smaller. So it can be anything like this, that size. It can be that much. Anything smaller than half the circle for a minor arc. Basic concept there. So that is the information that you need to know for this lesson. What you need to know then is how to plug that into what we're actually figuring out. So example 1 says, draw a circle with central angles that divide the circle evenly into thirds. So think about this. You have a circle, jumping back to this fact over here, it's 360 degrees. That's a circle, it's 360 degrees. So therefore, if you have 3 angles, what's the measurement of those angles going to be? Well, and they're all exact. So 360 divided by 3 gets you 120. And if you have a compass, which you guys probably don't have at home, actually, I think it's a protractor. You can use 120 and it'll get you exact thirds of your circle. You can use that information for anything. If you need to split it into 6 angles, 360 divided by 6 is what, 60? 60 degrees for each angle. So that's how you figure that out. Depends what your measurement is that they give you. Example 2 then, looking at a playground, and they have a circle, and it's painted on the blacktop, and it's formed by a circle with 2 intersecting diameters. Diameter goes the whole way across the circle, and they're intersecting. So it's 2 lines going the whole way across the circle, and they're intersecting. Then they tell you one piece of information. They tell you that one of the central angles measures 50. So I'm just going to, right here's the center of the circle, I'm going to throw a diameter that goes the whole way through. So there is 2 angles. You have one here and one here. They're both equal 180. You need another line in there to get 4 angles. And one of them is going to measure 50 degrees. So how do you figure out the next step? Well, you would take your measurement and go 50 degrees, which is probably right about here, and go across. So now this is 50 degrees. Now, it asks you, what's the measurements of the other angles? Well, what is the, if you remember from previous lessons, you actually do opposite angles are the same. So if you go directly across, you don't even have to measure this. This turns out to 50 degrees. This is a straight line. So the straight line, a straight line equals how many degrees? 180. Take 50 off of that. 180 minus 50 is 130. You can do the same thing over here, but opposite angles are the same. Therefore, those are your 4 angle measurements there. Jumping to example 3 then, you have a, it says, what's the measure of arc? That's what that little half circle, not half circle, but line over AD means. What's that in degrees? Well, they give you the measurement of 60 degrees, so you already know the answer. The measurement in degrees is 60 degrees. So actually, that's your angle. Nope, that's arc AD. So you know the answer for that. It's 60 degrees. They tell you that. You could get a measurement out and you could do that. What fraction of the circumference is the arc intercepted by ABD? So that angle there, what fraction is it? Well, think about this. 60 degrees, how many degrees are in a circle? 360. So what's the fraction? Cancel out the zeros. 6 over 36 is what is a fraction? It's 1/6. So your percentage is 1/6, or your fraction is 1/6 there. That's how much of the arc that you're taking up 1/6 of the circle. Then it asks you if the radius of the circle is 6 centimeters, what is the length of the arc in terms of pi? So if this thing, this measurement from here to here is 6, what's the circumference? Circumference equals pi times the diameter. What's the diameter? It's twice the radius. So 6 times 2 is 12. So the circumference is 12 pi. It says leave it in terms of pi, so 12 pi. Now let's ask, the next question is figure out the measurement of the arc. This right here. Well, how do you figure that out? Well, this fraction right here, it's 1/6 of the total circle. So just take this times 1/6. So the arc there is equal to 1/6 times 12 times pi. The way you figure this out is you reduce. So it is, the arc is equal to 2 pi centimeters for that. That is your answer for that. So that's how you figure that out. All right, I'm going to pause this and throw up the practice set here. All right, practice set. I'm going to do a giant circle here, circle-ish, and we're going to figure this out. So the first thing for A, they ask you, or they tell you, a circle is divided into 8ths, this right here. What is the measure of each acute central angle? So each one of these, what is the measure? How do you figure that out? Well, a circle is 360 degrees. It's divided into 8 equal pieces. So 360 divided by 8 gets you exactly, well, a calculator for this. 45. So each angle is 45 degrees there because you take 360, you divide it by 8, and that equals 45 degrees. That's A. Each angle is 45 degrees. For B, what's the measure of arc CD? Well, how are you going to figure out what the arc is? Depends how they want it. Do they want it in an actual measurement? Or do they want it in degrees? Which if they don't give you a measurement, you just figure out the degree part of it. So if each measurement is 45 degrees on the inside the whole way around, what is this out here in degrees? It's the same thing, right? It is the same exact thing because it's 1/8 of the total thing here, which, hang on here. All right, I just double checked that and I wanted to make sure. Yes, that is an accurate answer here. So each central angle is 45 degrees, and so then the arc is 45 degrees as well. So then question C, what's the measure of major arc CD? Major is more than a half circle, so how do you get a major arc between C and D? You go this way around. How do you think you figure that out? Well, you know that each one of these is 45, and it goes from this point the whole way around to this point, which encompasses 1, 2, 3, 4, 5, 6, 7. 7 of these 45. So you can do it two ways. You can do 45 times 7, or you can do 360 minus 45, because you have 360 degrees in a circle, and the only thing that you're not taking is this one right here. Minus 45 gets you 315 degrees for that. Now D takes it a little, gets an actual measurement from you. So it says if the diameter of the circle is 20, so from here to here is 20 centimeters, if that's what it is, then what is the length of arc CD? So between this point and this point, what is it? Well, what is their circumference? Circumference is equal to pi times the diameter. The diameter is 20, and it tells you to use 3.14 for pi. So circumference is equal to 3.14 times 20 for your diameter. So 3.14 times 20 is equal to 62.8. Circumference is equal to 62.8. Now, this is what fraction of the circle. What fraction of the circle is that? It's divided into 8 equal pieces, so that's only one of them. So it's 1/8. So you can do 62.8 times 1/8, or 1/8 of the circle there. So if you do that, 62, let's just see if that's what they're asking. Yeah, 62.81. All right, so it's 0.125 times 62.8 gives you an answer of 7.85 for that. So 1/8 times 62.8 equals 7.85 centimeters for that one. And that's the way you can figure it out. Now, here's an interesting thing if you want to actually find out if that's true. So if each one of these is 7.85, if you multiply that times 8, it will get you 62.8, which is true because there's circumference right here. We just figured out it's 62.8. So you get an answer for that. All right, hopefully once you're done watching this video, you all can come to school and actually do this in person.